Okay, guys, let's keep going with combinations. Here, days 2 and 3, and if you've been in class, you realize that this has really been pushed back a lot later than that. So today we're going to look at pizza. We're going to look at subs. We're going to look at a lot of great stuff. So here, more combinations. This is similar to the word problems that we're about to do in class. But the first question we can address is this: how many different pizzas can you make if you include these toppings? Now, we did this before when we had 2 toppings, right? So what we found out was there are 5 toppings to choose from, and we're going to put 2 on a pizza. That's the way. So that's 5 factorial over 3 factorial, 2 factorial, and we figured out, I believe that's 5 times 4 divided by 2. I think there's 10 different pizzas. So that's for the number of 2 topping pizzas. We could go through the whole thing and add this up like this, and add it to the 5 topping pizzas, the 3 topping pizzas, the 4 topping pizzas, and the 5 topping pizzas, which would just be 1. And also, we would also probably have to consider the no topping pizzas, right? Like a cheese pizza. So we could go ahead and do that, and that would be interesting. But there's a quicker way to do that, and that is a different way to think of that is to say for each topping, this is what I wrote here, it's like generating a giant yes-no tree. You go through the pizza and you say, should we have pepperoni or no? Should we have bacon or no? And each step is addressing that question for each topping. And you go through it and you keep going through it and yes or no, yes or no, yes or no. And if you start asking yourself how many different pizza options are there, well, there's 2 here times 2 here. Now we're at 4. Now we have 8 branches, 16, and then we end up with 32. So in general, the total number of subsets of n elements of any size, you don't necessarily need to write that in there because we haven't described the size, so we're going to assume it's any size, is 2 to the n. Okay, so you make a yes, no, a yes, no, a yes, no, and very simply, if you want to ask yourself how many pizzas can you make, it's 2 to the n. Okay, now that said, you got to be careful with this. Is in some cases the empty set doesn't count. So what does that mean? That means in this case we said we have a pizza and a cheese. So we start off with just cheese on top or nothing on top or whatever, and then we start throwing stuff on top of that to get our 2 to the n different combinations. One combination is with no toppings. Now in our life, that's okay. In our question, not our life, but our question, the pizza question, you can have a pizza with no toppings, and that's considered a pizza. But for example, if you said, look, I have 5 pictures, okay, on the wall, and I'm going to choose from, and I'm going to put some of them on the wall. Okay, I need to take some of them on the wall, and I definitely am going to put one on the wall. Well, 2 to the 5 is the number of different combinations you can have, right? If I don't say I need 1 picture, 2 pictures, 3 pictures, or 4 pictures, or 5 pictures, if I can have as many as I want. But if I've said, listen, I'm going to put one on the wall, then the no pictures on the wall, which is this one, 5 choose 0, doesn't count. So that's 1. So we need to subtract that. So if the null set or the empty set, is both, doesn't count, then we're going to get rid of it and just say 2 to the n minus 1. Okay. So for example, if you're going to take shoes with you on a trip, so here's a good question. You're going to take shoes with you on a trip. How many? And you have 3 pairs of shoes. Okay, assuming that you're going to take a pair of shoes and not just a left shoe. And there's no combinations of left and right of shoes that don't match. That's just crazy. You would have 2 to the 3 options total, but you need, so for each pair of shoe, you say yes or no, yes or no, yes or no, yes or no, all the way through, and it's 2 to the 8, but you are traveling, so you have to say to yourself this, you need shoes, everyone needs shoes, so I'm going to say at least the one, sorry, I have to get rid of the empty set. The no shoe selection doesn't count. Okay, so that's how that works. Someone just knocked on the door, distracted me. Okay, so now we can finally figure out how many different combinations of subs there are. And we're going to do this in class. The reason I won't do it right now is because there are different options we're going to talk about in class. So I'm going to let that go. Enjoy. The number's going to be big. And then what I want you to do is by Monday, try all. I'm just kidding. Back to cards, 5 card hands. So let's see where this goes here. We have this. We're going to have a pair of aces. So how many aces are there? 4. I'm going to choose 2 of them. And then 48, I'm going to choose 2 not being in there. Okay, so it kind of mumbled there. I want 2 aces. And I want 3, I'm wrong here. That's 3 non-aces. Okay. How many hands include at least 2 aces? So what you want to do here is you want to look at this and say at least 2 aces would be this, 2 aces. So you have this situation, and at least 2. So this is nothing really new. And you can have how many? You just got to keep track here. How many aces can you have? That's 48 here. You can have up to 4 aces. So there's that. And each time you take an ace, an extra ace, you're choosing one less of these cards. Okay, so you add them up. At least 4 diamonds. So when it comes to diamonds, you're going to have 4 diamonds. Remember, there are 13 diamonds to choose from. And there are, well, 13 subtract 52 subtract 13 is 39 non-diamonds, right? So you can have 2 diamonds, and you're going to also have, sorry, you can have 4 diamonds, and you're also going to have 5 diamonds. How many hands include the 5 of spades and or the 5 of clubs? So how many have the 5 of spades and or the 5 of clubs? I guess we could do it 2 different ways here, but let's just do it this way. We're going to do the 5 of spades by itself. So here, I guess there's 2 ways to talk about it. One, just the 5 of spades. One, just the 5 of clubs. And then one where you have both of them. You just got to be careful with the double counting. So this question is a little bit trickier than what you think. I think the best way to do it is to do them separately and say, look, I have, there are many ways to do it, and you might get the same answer. I'm just going to be careful here, and I'm going to have 2 of these cards. So what I'm going to do here is say 5 of clubs only. So 5 of clubs only. And what happens there is I'm going to choose the 5 of clubs, and then I'm going to choose the 5, and then not choose the 5 of spades. So then I ask myself, of the other 50 cards, I'm going to choose 4 of them. Okay. I could do this too. I could say I'm going to choose one of the 5 of clubs. I'm not going to choose the 5 of spades. Okay, but that's just 1 and 1. And then I'm going to multiply all that out, and that's choosing 4 cards out of the 50. And then I'm going to do the same thing where I've taken the 5 of spades. So if I do that, I choose the 5. Here's the 5 of clubs. I don't choose the 5 of clubs. I do choose the 5 of spades, and then I'm left with 50. This. Now, is this the only way to do it? No, but this is one way to do it. And the other way would be to say I'm going to choose both the 5 of clubs and the 5 of spades, and that leaves me then with, of the 50 non-5 of club, 5 of spades, I'm going to then take 3 of those. Now, have I double counted? I don't think I have, because this here is both of them, and I've specifically said no here, no clubs here, no spades here, or vice versa. So I think that's the best way to do that one. Okay. What's more likely to occur? 5 cards are dealt at random, a flush or a straight. We'll do that in class. There's many answers to this. This is a upper level type question, and if you don't want to do it, don't. But if you got it, good. Okay, so that's it for this unit. Any questions? Come and see me.